Right now, you are sitting on a planet wrapped in a blanket of air so thin, so fragile, that if you drove a car straight up, you'd be in the vacuum of space in less than an hour. You've never thought about the air around you. Why would you? It's everywhere. It's everything. It's the invisible sea you swim in every second of your life. But what happens when the air starts to leave? 408 kilometers above the surface of the Earth, traveling at 17,000 miles per hour, there is a place where human beings sleep. They eat. They work. They laugh. They breathe. The International Space Station, the largest structure humanity has ever put into orbit, is essentially a collection of sealed aluminum tubes, pressurized metal chambers, stitched together over 25 years of assembly missions, holding a thin bubble of breathable air against the merciless vacuum of space. It is one of the greatest engineering achievements in human history. And one night, without any warning, it started to breathe out. To understand what happened, you first need to understand what it means to live here. The International Space Station is not a ship. It's not a vehicle in any sense you've experienced. It is a neighborhood, a collection of modules, each one about the size of a school bus, connected end to end, arranged in a cross shape larger than a football field from wing to wing. Inside those modules, 6, sometimes 7, human beings make a life. They wake up in sleeping bags velcroed to walls. They eat food squeezed from tubes and packets that float away if you're not careful. They exercise for 2 hours every single day, not for fitness, but for survival. Because without gravity, the human body begins to quietly fall apart. Bones weaken, muscles vanish, the heart shrinks. They are the most isolated human beings on Earth. Except they're not on Earth. They are separated from instant death by walls approximately 4.8 millimeters thick. To put that in perspective, the shell of a standard aluminum can is about 0.1 millimeters. The ISS hull is roughly the thickness of 5 stacked pennies, standing between the crew and a vacuum so complete that exposed human tissue would begin to boil within seconds. Scientists call it hard vacuum. The word hard does not do it justice. And in the year leading up to this incident, something in that paper-thin shell, or rather, in the seals and joints that hold the modules together, had begun, almost invisibly, to fail. Pressure. On the International Space Station, everything comes down to pressure. The station is maintained at a pressure roughly equivalent to sea level on Earth, 14.7 pounds per square inch. That number is not arbitrary. It's the pressure that allows human lungs to work properly. The pressure that keeps your blood in a liquid state. The pressure that makes life possible. And on Earth, that pressure surrounds you everywhere. You never notice it because it never changes. On the ISS, someone checks it every single day. The leak was first detected years before this crisis. A small anomaly. A pressure reading slightly lower in the morning than it had been the night before. Engineers noted it, analyzed it, searched for the source. They found nothing definitive. The station has hundreds of meters of seals, joints, hatch gaskets, window frames, docking port collars. Finding a microscopic crack in any one of them is like finding a single broken thread in a cathedral's tapestry. So they monitored, they tracked, they measured the rate of pressure loss, a few hundredths of a PSI per day, and they calculated. At that rate, there was no immediate danger. The station carries reserve nitrogen and oxygen to compensate. The situation was, in the language of NASA engineers, manageable. But manageable is not the same as solved. And something else scientists still don't fully understand. The leak wasn't constant. It was variable. Some days worse than others. Some nights, the pressure held steady. Others, it bled away faster than any model predicted. The station, it seemed, was breathing in a rhythm all its own, and nobody could hear where the sound was coming from. What changed was the rate. For months, years, the leak had been a slow concern, noted, tracked, and filed alongside 100 other items under observation that are simply part of operating the most complex machine ever built. Then, over a period of weeks, the numbers began to shift. What had been a trickle became something more. The daily pressure loss increased, then increased again. Measurements that had required sensitive instruments to detect were now visible in the broader system logs. Mission controllers on both sides of the world, in Houston and at Roscosmos Mission Control in Korolev, Russia, began paying closer attention. The ISS is an international partnership unlike anything else in human history. American astronauts, Russian cosmonauts, European scientists, Japanese engineers, all sharing the same recycled air, the same water processed from their own exhaled breath, the same fragile metal home. When one part of that home shows stress, everyone feels it. Teams began what's called a leak isolation procedure, a methodical, painstaking process of closing hatches between modules one by one, sealing sections off, and watching pressure readouts in each isolated compartment to triangulate the source. Close the hatch to the US segment. Wait. Measure. Close the hatch to the Russian segment. Wait. Measure. Close the Soyuz docking port collar. Wait. Measure. It's like playing hide and seek in a tin can 250 miles above the ground. The investigation pointed, again and again, toward the Russian segment. Specifically, toward a section in the Zvezda service module, the oldest continuously inhabited module on the station. The structural heart of the Russian side, built in the 1990s, launched in the year 2000. Old by space standards, experienced. And somewhere in its aging frame, air was escaping into forever. The crew was sleeping, or trying to. On the International Space Station, sleep is its own kind of science. Astronauts use specially designed sleeping bags attached to the walls of individual crew quarters. Small, cabinet-like spaces carved out of the module walls. With no up or down, no darkness that comes naturally, an orbital sun rises every 90 minutes. The body's internal clock has to be chemically assisted and carefully managed. That night, as the crew slept, the pressure aboard the Russian segment of the station dropped faster than it had in months. Flight controllers in Moscow watching overnight telemetry saw it first. The numbers were unambiguous. This was no longer a slow, manageable seep. The rate had accelerated. Protocols were activated. Wake the crew. And here, you must understand what it means to wake up in that situation. To open your eyes in a sealed metal tube, floating in zero gravity, and be told by a voice on a radio, the air is leaving. You cannot open a window. You cannot go outside. You cannot run. There is nowhere to run to. In the darkness above the Pacific Ocean, traveling at the speed of a bullet across an orbital path no human foot has ever touched, the crew of the International Space Station made their way to the SpaceX Dragon capsule. Not in panic, not in chaos, with the focused, practiced calm of people who have trained for years to be afraid and function anyway. The Dragon capsule, called Endurance, was docked to the station as part of a NASA commercial crew mission. It is, among other things, a lifeboat, a pressure-sealed emergency refuge, independent of the main station systems, capable of carrying the crew back to Earth if the worst ever came to pass. They sealed themselves inside. 4 astronauts and 3 cosmonauts, 7 human beings, in a capsule roughly the size of a minivan, hovering 250 miles above the ground, waiting for the data to tell them what to do next. Think about what that waiting feels like. You are inside a vehicle smaller than most people's living rooms. Outside that vehicle is a space station where something is wrong, though you don't yet know how wrong. And outside the space station is one of the most hostile environments in the known universe. A place where the temperature swings 500 degrees Fahrenheit between sunlight and shadow, where radiation from the sun would strip an unprotected human body to molecular components in minutes, where there is not a single atom of breathable air for hundreds of miles in every direction. You sit, you wait, you breathe, and you think about how much you love the air. While the crew waited, the engineers worked. This is perhaps the least cinematic part of the story, and yet the most extraordinary. Because what happened next wasn't a dramatic spacewalk. It wasn't an explosion. It wasn't a desperate, last-second save with seconds to spare. What happened was human beings, on the ground, doing math. Very good math. Very fast. By measuring pressure curves in isolated sections of the station, comparing rates of change in sealed versus unsealed compartments, flight controllers were able to triangulate the primary leak location with increasing precision. The Zvezda module, a specific area near the transfer compartment, a junction where modules and docking ports meet. The cracks themselves are microscopic. Not a catastrophic breach, not a hole you could stick your finger through, something closer to what engineers call microfractures. Tiny imperfections in welds or structural material that, over years of thermal cycling and mechanical stress, had slowly propagated. Every time the station moves from sunlight into shadow, the temperature swings 270 degrees Fahrenheit. Every 45 minutes, 96 times a day, year after year, for 25 years. Even metal gets tired. Scientists still don't have all the answers. The precise origin of every leak path in the Zvezda module remains, as of this telling, not fully mapped. The station is too complex, the measurements too difficult, the access too limited to guarantee certainty. But what they determined, definitively, that night, was this: the rate of pressure loss, while elevated, was not immediately life-threatening. The station's reserve oxygen and nitrogen supplies could compensate. The situation was, in Mission Control's measured language, stable. The crew, huddled in Dragon, heard these words through their headsets. Stable. Not solved. Not fixed. Not over. But stable. They went back in. Not because the problem was solved. It wasn't. Not because the leak was gone. It wasn't. But because 7 human beings had looked at the data together across 2 continents and 2 space programs and 2 languages and decided, we can continue. This is, when you think about it, the most human thing in the story. Not the engineering, not the technology, the decision. Because the International Space Station has always been, at its core, a decision. A decision made 40 years ago by nations that had spent decades pointing missiles at each other to instead point rockets at the stars, together. A decision made by thousands of engineers and scientists and managers and astronauts to believe that the problems of living in space could always, eventually, be solved. The crew returned to their duties. Work continued. Experiments ran. Data accumulated. And the engineers, on the ground and aboard the station, began the long, painstaking process of developing solutions. Specialized sealants applied in patches to the identified crack areas. Improved monitoring systems to track pressure with greater sensitivity. Ongoing leak isolation tests. The situation, in the months following, improved. Not all at once. Not dramatically. Slowly. Methodically. With the kind of patient persistence that keeps complex machines alive across decades. There is something the air leak teaches us, if we're willing to listen. Not a lesson about engineering, though there is much of that to be learned. Not a lesson about space travel, though it contains multitudes. A lesson about what it takes to stay somewhere you were never meant to be. The universe does not want human beings in space. This is not poetic, it is literal. Every law of physics conspires against us. The vacuum, the radiation, the temperature extremes, the bone-thinning weightlessness, the psychological weight of distance. Space is not hostile because it hates us. It is hostile because it simply is, and we are very, very small. And yet, there have been human beings living continuously aboard that tiny bright dot since November of the year 2000. More than 2 decades without a single day, without a human presence in orbit. Through hurricanes and pandemics and political crises and economic collapses and wars and elections and all the churning noise of life on Earth. 7 people have lived in that metal cylinder, doing science, fixing problems, breathing recycled air and drinking processed water and watching the sun rise 16 times a day. A hissing crack in an aging Russian module was not going to end that. Because ending is not what human beings do. We seal the cracks. We hold the pressure. We go back in. From 408 kilometers above your head, they are looking down at you right now. All of us, all our cities and arguments and heartbreaks and meals. A blue marble in a black sea. And the air that surrounds you, that you have never once thought about today? They know exactly how precious it is. As of 2025, the International Space Station remains crewed and operational. The Zvezda module leak has been partially sealed using specialized sealant compounds. Monitoring continues. The mission continues.